Now, what is round robin? The name implies here. You know, there is some one game like this. Whether you played in school or just I will show you. Mostly like the students be standing in some circle and the ball will be at the center. So they will be given some time for each students to take the ball and throw. They will go in circle. They will go in circle. Like you know music chair. You know music chair, right? Do you know music chair? Game? Yes or no? There will be only one chair in the center. A music will be played. Once it is stopped, relaxes like one after another, one after. Here, round robin scheduling algorithm is based on the time sharing system and considered to be the most commonly used scheduling algorithm. Time sharing system means if we have the process P1, P2, P3, P4. So we have the process P1, P2, P3, P4, and this is your CPU. For example, the time quantum is very important. This CPU will allow the process to execute only for like 2 seconds or 3 seconds or 5 seconds like that. Only that particular second the process can execute and then it will go back. For example, the P1 first time is 10. First time is 10. But the CPU quantum time is 2. CPU quantum time is 2. So what is the meaning here? That means the total burst time is 10, but it will execute only for 2 seconds. Again it will go back. Next P2. Again P2 will go back. Next P3. Again P3 will go back. Again P4. Again P4 will go back like that. Okay. So how many times the P1 has to execute? The P1 has to execute at least for how many times? The P1 has to execute for 5 times. That means it will come to CPU for 5 times. So first time 2, second time 2, third time 2, fourth time 2, fifth time 2. So it will keep on coming again and again, again and again. Understand? Here, the next process is in the ready queue. Will get the chance to execute. The incomplete process goes back at the end of the ready queue. The process selected are ready queue in the first come first serve manner. It is similar to first come first serve manner, but it is preemptive. It is preemptive. Preemptive means it will come back again to the process. It will come back again to the. I'll tell you one thing here. I'll explain. Listen carefully. What you need to do is listen. And then I told you the time quantum is very important. Okay, this is the problem. How many processes are there? How many processes are there?
Only three.
Only three, P1, P2 and P3. The process burst time is 8, 6 and 5. Read the question carefully. Calculate the average waiting time using round robin where the time quantum is 2 milliseconds. They will give the time quantum. Time quantum is very, very important. Time quantum equal to 2 millisecond. That means what? That means each process will execute only for 2 seconds. Only for 2 seconds. See here. P1. Is it 0 to 8 or 0 to 2? See that Gantt chart I drawn here. I didn't write 0 to 8. 0 to 8. You know why I didn't write 0 to 8? Because the time quantum is given only 2 seconds. That means P1 can execute only for 2 seconds. and then it will go out, and then P2. P2 is also 2 seconds, and then P3. P3 is also 2 seconds. So one round is over. Round 1 is over. So after completion of round 2, like here I will write -2, -2, -2. So remaining time is what? Remaining time is 6, 4, 3. You understand? Or you want me to repeat? You want me to repeat? I will repeat. You want me to continue? I will continue.
Continue, Mister.
See, this is round 1. This is round 1. In round 1, all 2 second over. So 2 second over means what is the remaining time? 8 minus 2, 6. 6 minus 2, 4. 5 minus 2, 3. So again P1. So again P1 means -2, -2, -2 like that. So if you do minus here, just add it here. So 8, 10, 12. So this is round 2. This round 2 is complete. Round 1 is complete. Round 2 is complete. So P1 I am adding 2 second. P2 I am adding 2 second. P3 I am adding 2 second. So after round 2, so remaining time is what? 4, 2, 1. 4, 2 and 1. Okay. Now again what? Again P1, P2, P3. So P1 I'm just adding 2, P2 I'm adding 2, but for P3 I'm adding 2 or 1. What is the remaining time for P1? See, just I'm adding means I'm subtracting here. 2 minus 2, it is 0. And here I'm no need to minus 2 because it's already only 1. It's already only 1. So here the P3 will be what? P3 will be only 1. So 16 plus 1 is 17. So already the process P3 is over, and the process P2 is also over, and the process P1 is there. The P1 time is left out is 2. So 17 plus 2 is 19. I hope everyone you understand why I'm adding 2, 2, 2, 2 here. Not like 0 to 10 and 0 to 8 and then like 14 like this. Because it is round robin. It is round robin algorithm. Round robin algorithm means that particular process will execute for some time and then give the chance for other process. Continue or repeat? The
Continue.
other things are same. See, now what will happen here? The waiting time will be turnaround time minus burst time. Okay, so what is the waiting time for P1? The waiting time for P1 here is, so what is the turnaround time? Turnaround time is 19. 19 minus burst time is what? 8. So the waiting time for P2, check the last P2, 16. Turnaround time minus 6. The waiting time for process P3 is 12. P3 is not 12, 17. So 17 minus 5, 12. So this is the waiting time, and then I need to calculate the average waiting time. Okay, understand? Shall we do one problem or continue? Shall I repeat? Shall I do problem or repeat? Either tell this or this. When I toss the coin, you have to tell either head or tail. If you are silent like this, what can I do? The coin will not stand straight. Either it will fall head or tail.
Mr.
Yeah.
Last step.
Hmm.
Why we take the last verse 19?
19,
Why we take it this number?
because 19 is the turnaround time. What is the turnaround time for P1? 19. You know,
Yes.
19 is the turnaround time for P1. Because that is after completion of P1, the turnaround time is 19. Because this 17 plus 2, 17 plus 2 will be 19. Just tell me how many times P1 comes. Just tell me how many times P1 will come. 1, 2, 3, 4. You know why? 8 divided by 2 will be how many? 8 divided by 2 will be how many?
4. 4.
4. So 4 times P1 will come. How many times P2 will come?
3.
Yes. So P2 will come 3 times. 1, 2, 3. See here. 1, 2, 3. How many times P3 will come? 5 divided by 2. How many times P2 will come? It is 2.5, right? That means 3 times, right? 2 and 0.5 3 times. Like 0.5 is 1 year. So I consider here P3 1 times, 2 times, and adding 1 year. So 16 plus 1, 3 times. So you can calculate how many times each process will come. How many times each process will come. Okay. Now you have the self-study, this self-quiz, all those things. I'll check out. Yeah, this problem. Execution time, arrival time, order zone. Time quantum is given. Okay, we'll go into the lab manual now. I finish this one. We'll do one problem, lab manual. Open your lab manual, go to round robin. Come to round robin. Where is round robin? Do all these things, okay? Whatever given here in lab manual, just do it. Then only you will understand. So round robin. Now shall we take this problem and we'll do it one, okay? Now I will do this one. No, I will not do. You want with 2 or 5? This is completed, right? Just now we completed. Okay, no need of this. I'll do this because the first one already completed. Yeah. Who will help me out now? Yes. Okay. Now you don't draw. Like for example. Okay, I'll do like this. I will calculate and I'll do it. Okay. Now tell me how many times P1 will come. What is the time quantum given here? What is the time quantum given here? Time quantum equal to
5
what?
seconds.
Very good. Time quantum equal to 5 seconds. Now just tell me how many times P1 will come. 20 divided by
4.
3. How 3?
4, not 3.
4, Mister.
Times P1 will come. How many times P2 will come?
5.
5,
P3 will come.
2,
P1, P3 will come. So this is for how many times P4 will come?
3.
3.
So for example, if I give 17 here, how many times P4 will come?
Mister. 10 divided not 2. You wrote 10 divide 2.
Now if I give 17, how many times P4 will come?
5.6, but it's wrong.
Here I'm giving, instead of 50,
3.4.
I'm giving 17. 17 means how many times it will come, I'm asking.
3.4.
3.4.
Means
4.
times. Yeah. 3.4 means 4. See these 4 times, how we divide? 5 plus 5 plus 5 plus. Or no. The first time 5, second time 5, third time 5, fourth time 5. So you should know how many times it will come. So like this, for example, this is 15, 5, it will be 3. Now you calculate this one. 4 plus 5, 9, 11, 14. So 14 times I need to do the process. Number of so if you want, the first process will be what?
B1.
So P1 time is what? 0 to
0 to 4.
okay, 1 minute. Okay, I'll take this one. Or I'll do one thing, wait. So it will start 0 to
5.
0 to 5, right? Next, again P2, again, again, again we have P1, again we have P2. So this will repeat, P1, P2, P3, P4 will repeat here. And then again this also will repeat. Now later. Now this tell me, you tell me this. Now how much? 5 to what?
From 5 to 10.
10 to
15,
15,
into 20. Yes.
25,
Yes, 25.
30,
E.
35, 40,
Is it correct? Now you check here. Here, see for example, I have the process P1, P2, P3 and the burst time. So I have process P1, P2. This is the burst time 20, 25, 10, 15. In the first round, 5 is over. 5 is over. Is over. 5 is over. Remaining is what? Like 15. Remaining is, so remaining is 5. The remaining is 10. Okay. So in one round, so I completed P1, P2, P3. In second round, so this is second round, minus 5, minus 5, minus 5, minus. Second round, 10, 15. That means P3 will come only 2 times, right? P3 will come only 2 times. Yes or no? Now can you see here? P1, P2, P3, P4. Again P1, P2, P3, P4. So just I put number. Next in third round, see this is the third round. You get P1, you get P2. No P3. P3 will come in third round. Will P3 will come in third round?
no, Mister.
No, because it is only for 2 times. It is only for 2 times. And the P4 will come because P4 is 3 times. So P4. So third round is also over. And next fourth round. Fourth round is what? Round 2 round. Here minus 5. 5. And this one minus 5. So how much it is there? 10. Sorry, this is 5. This is, and this is. After third round, P3 is over and P4 is also over. Okay, fine. Next, what is remaining? P1 is remaining and P2 is remaining. So here you will get P1 and P2. Now again P2. So tell me how many times P2 comes, P1 comes? 1, 2, 3, 4 colors. Yes or no? P1 4 times. P2 how many times? P2 how many times? 5 times, right?
yes,
2, 3, 4, 5. And P3 how many times? 1, 2. P4 how many times? 1, 2, 3. So that is why I just put it here. You should know how many times each process will come. How many times each process will come. Okay. See this one. You have done like this, but like before, no, you can do it. It's not coming. You just try to write here. Like Right, 0 to 5. Zero to 5, and then 10, and then 15, and then because every time you are adding only 5. Okay, 40. I want to write it like that. Do you understand here? Is it okay? Okay? Or you want me to explain different? And then you know what is meant by waiting time and what is meant by turnaround time, how to calculate. Waiting time, what is meant by waiting time? What is meant by turnaround time? What is the average waiting time? Like how we did here. Can anyone tell me? For P1, what is the okay, dear. Anyhow, I will explain this one. I'll try to be in better presentation. I'll check out. Okay. But I hope you understood. You can draw it in the paper also. You can draw it in the paper and you can do it. No worry. Any doubt? And then please try to complete all the activities, whatever the activities which we have seen now, and including in chapter 4. Okay, including in chapter 4. My part is over, dear. Even for midterm exam, my part is over. Whatever I want to teach, whatever I want to tell, I am finished. You have another 2 class for your doubt clarifications. Anything regarding your scheduling algorithm, regarding your basic commands, regarding your scenario, anything you want, you can discuss. Next 2 class, I am going to discuss. Next 2 class, I am going to discuss. See here, all these scenarios, just go through these review questions and this self quiz. Which algorithm is used in the case of tie between the process? If there is the tie between the process, which process will be utilized? Why is the SGF algorithm difficult to implement? The round robin algorithm is the variation of which algorithm? What is the difference between preemptive and non-preemptive? What do you understand by CPU scheduling? Which one is best and why? Calculate the turnaround time and waiting time for the process. Discuss the multiprocessor scheduling. Discuss the functionality of multi-level feedback queue scheduling. Discuss the performance criteria for CPU scheduling. Some problem, everything is given. Try to find out the answers, you work out and upload it. You may get the questions like this in your exam also. Because you know that exam. I hope already you got your timetable for your, I think midterm is on. When is our midterm? Is it 14th or 12th?
14.
14th, okay. So the exam is on 14. Hardly you have another 2 weeks.